All right, let's look at this situation where a double bond can be shared between one or two or more bonds. It's called resonance. The first example I'd like to use is ozone. Oh, and this is page 319 to 321 in your textbook. Let's do the Lewis structure for ozone. I've got 3 oxygens connected. 3 oxygens, each with 6 valence electrons. That's 18 valence electrons available. 1, 2. Let's give them an octet. Eight, 16, 18, 20. I got too many. I got to make a double bond. But I got options here, right? Where do I put it? Do I take these out and put it here? Or do I take them 2 from here and put it there? It seems like it's either one. It doesn't matter. Where it is actually it's partially both. So let's draw the 2 options. Or notice when I switch that double bond over here, I got to make sure I'm not violating the octet rule with this. So I took that unshared pair and moved it here. So the double bond, we would say, well, it's got to be either here or here. It almost looks like with this molecule, did I just flip it? No, actually the situation is that it's not or, it's and. The double bond is being shared between the two bonds, the 2 OO bonds. So we say it's a partial double bond on both. Conceptually, it's almost like this. Kind of showing a partial double bond on both, but you can't do the Lewis structure there. That would be a nice shortcut. So when you're doing the Lewis structure, you actually have to draw both with a little kind of arrow showing both. So you have to draw the double bond in both places, the 2 different Lewis structures. So when we have these resonance structures where I have a double bond that's shared between 2, I can't just draw one structure. I got to try to show the double bond in both places. Let's look at another example. The nitrite ion. Nitrogen has 5 valence electrons, 2 oxygens, each with 6, that's 12. Negative ion, add 1, 18 valence electrons. This is going to be a lot like ozone, right? Connect the nitrogen, oxygen, oxygen. Give them an octet. Where does so then I've got too many. I got to put a double bond. Where does it go? Both places. Not 2 double bonds, but I got to show it here and I got to show it here. So my Lewis structure for the nitrite ion is going to be this. I kind of skipped the step. Whoops. Sometimes when you skip this step, you can get the wrong number. So 2, 4, 6, 8. There's my 8 and there's my 8. So double check your octet rule. It's an ion with brackets around. So the double bond is partially on that left NO bond, and it's partially got to shrink this down to fit it on the whiteboard. And it's partially on the right. So we'll look at this that the double bonds are a little bit shorter. They kind of pull in tighter. So that but the bond lengths are equal. Those are equal bonds with 2 bonds that we say partial double bonds. And so is it always just 2 like that? No, sometimes it can be more. Nitrite. Go ahead and pause the video and tried doing the Lewis structure for the nitrate ion, NO3-. Let's try that one. So here is the solution for the Lewis structure for the nitrate ion. When I first gave them all their octet, I had counted 8, 16, 24, 26, too many. I only have 24. I had to put a double bond in. Since there's 3 equal bonds, the double bond is actually shared between the 3 NO bonds. So what do I got to do? Isn't there a shortcut? No, I had to draw all of that, right? So you have to show the double bond in each location, but the implication is it's not this thing where first it's here, now it's here, then it's here. It's actually partially in all 3 places, that double bond being shared between the 3 bonds. We'll see when we're looking at the atomic orbitals what this looks like. But that is the correct Lewis structure for the nitrate ion, showing the shared NO double bond. We will continue to work with these and do more examples as we practice more Lewis structures.